So, hi and welcome everybody. Welcome to the Wireless Communication Systems. In today's lecture, lecture number 1, we are gonna give you an introduction about wireless systems. Basically, we will give you historical background about wireless systems, how they are developed, and what people had used to use in the old days to communicate their messages over very long distances. And the agenda is going to be structured as follows. Basically, first we are going to talk about wireless history, then the wireless vision, followed by technical challenges. Then we are going to discuss and talk about the currently existing wireless systems like 2G, 3G, 4G, and the next generation wireless systems covering 4G and even talk a little bit about 6G and some advanced Wi-Fi related technologies, as well as Li-Fi technology, which is a visible light communication kind of technology. After that, we are gonna talk a little bit about spectrum regulations and the standards, what the government does regarding this, how does it allocate spectrum to companies to use, to users to utilize, and the regulations related to this, the standards, the cost, how much is the cost of owning 1 megahertz of bandwidth to transmit your data over. Then after that, we will focus our talk on covering emerging wireless systems. So let's get started with the wireless history. So in the ancient eras, like before thousands of years, people needed to communicate with each other. It's basically a key kernel need for most people, regardless of the era they are living in. They need to communicate and send messages fast and reliably. They have to send their messages fast enough and reliably enough. So they used to use smoke signals for sending messages. They use the smoke in order to modulate a certain signal that they want to convey over a very long distance. They use the flags like, for example, if you raise white flag, it means the enemy attacked us. If you raise the red flag, we are in a very difficult situation. If you raise the green flag, it means you are winning, you are doing very well. Or you can change the meaning of the codes as long as you share these meanings between the transmitter and receiver so that they can understand each other. We have carrier pigeons. They used to carry messages from one part to another. So these means were the only available means in the old ages until Marconi invented the radio in 1880s. So with the invention of the radio, for the first time ever in the history of humankind, you can use wireless signals, things that you cannot see in your eyes, to send and receive data. So that was a game-changing event for humanity. Like, you can send things over a very long distance without even seeing the carrier. This is not pigeon, this is not flag, this is not smoke signal. This is something called wireless that nobody has ever seen unless you are an expert working on this domain and you can use spectrum analyzers to see them and visualize the signals in the air. And therefore, this year kind of the starting year of the innovation in communication systems. Of course, it was analog, it was basic, but it was like magic at that era. How can you communicate with someone who's far away from you, thousands of kilometers, within seconds? So how does this happen? It's impossible. So many sophisticated military radio systems were developed during and after World War II. one of the main reasons why some countries won the war over others is radio systems. The countries that were using radio systems and they were able to secure their systems reliably and make sure nobody can crack it are the ones who were capable of building empires. Like, let me give you the story of the British Empire. British Empire became an empire just after cracking the secret codes that Germans used to use in World War II. So they hired mathematicians and people who are expert in cryptography so that they can analyze the traffic, the radio signals that are being communicated between the military soldiers of German. And by decoding these signals, they were able to discover the code that the German army uses for sending and receiving signals. And these codes were updated each and every day. So they were they had to guess this code at the beginning of each day so that they can get and read all the messages by next day. This is the main reason why Germany lost the war in World War II, because of leak of information to their enemies. So this shows you the impact and the huge sensitivity of making sure that your system is secure, because anybody can get into your system and get your information out of you. Then you are prone to attacks. Your operations are not gonna be run successfully, and you have kind of an internal enemy inside of you. So that's the main reason why Germany lost the war and why new empires ruled over the world. This is the main reason. I read this from many books on security, and these books, they talk about history of how things were done in the past. So I can even share the book with you so that you can get more information about this. But this is key, this is important. This shows you that a system that's not secure is not gonna be so effective, and security and communication comes hand to hand, side to side. You cannot talk about someone without talking about the other. We have mainly three key requirements to build a successful communication system. One, we have to make sure that we can send enough amount of data for the intended receiver. Second, we have to make sure that this data can be transmitted reliably, which means with minimal amount of errors. Third, you have to make sure that it's secure. Only the intended user can receive this data and decode it successfully back. Otherwise, your system will not be considered a successful communication link. So after this era, World War II, we have seen the world has seen exponential growth in cellular use since 1988. So approximately 8 billion worldwide users today, all of them are connected to the wireless network, which is the cellular network. This basically ignited the wireless revolution. Voice, data, and multimedia are now ubiquitous, available everywhere. You cannot imagine your life living without having access to the applications that allow you to communicate and send and receive data over the internet. So our daily life has become dependent significantly on these applications. So it's even used in third world countries, and this is growing rapidly. So it means that regardless of your financial level, whether you are rich or poor, it doesn't matter. It has become a basic living need. You cannot just say I would be able to live and survive without an access to the internet or without having wireless connectivity. Everybody nowadays is exposed to wireless signals, whether you are at home or at office, or you are commuting from one place to another. You are always checking your emails, your messages, your WhatsApp, your social media, your things, your work, your life, your friends. Everything is just condensed inside of these applications. So one of the most important and key technologies that enabled billions of users to enjoy the fruits and the benefits of the internet is Wi-Fi technology. And it has been a tremendous success because it has been really cheap. Most people can afford it, and with the growth of applications that are extremely useful to your daily life routine and daily life jobs and tasks. So you have become really in need of Wi-Fi connectivity wherever you go. So you cannot imagine being isolated or disconnected from the internet for a period longer than one day. You feel something missing in your life. Beside Wi-Fi, we have the Bluetooth. It has been really pervasive technology. Satellite is also widespread, but it's mostly used by governments in the world. It's not. I cannot remember. I cannot see nowadays any system that gives satellites connectivity to normal people to communicate over, because it's very costly, very expensive, and it causes too much latency and consumes too much power from your battery. So that therefore it's used just for certain purposes, like the military need to use it in areas where the area is really very far from normal wireless networks like cellular. Cellular cannot reach and cover those far areas with wireless signals. That's why the only way to cover them is by satellite. And in these cases, you would find yourself in need of using satellites in order to run your operations successfully. What about the future wireless networks? So wireless is ubiquitous communication among people and devices. So not only people, but also devices have also to connect with the internet and send and receive data. So wireless is affecting and many areas in our daily life, but like we can see next generation cellular Wi-Fi networks emerging, smart homes, spaces, autonomous cars, smart cities, body area network, Internet of Things, and all of these are not are basically heavily dependent on the existence of something called wireless link, on something called wireless communication. Without wireless, all these applications and use cases wouldn't ever exist. So now then, if we were to build really good, robust, resilient, reliable, secure wireless communication systems, then what are the challenges and the difficulties that are faced by communication engineers who are working to build robust communication systems? So we have many challenges. Usually, if you ask any communication engineer working in companies like Google, Apple, Huawei, Ericsson, Nokia, ZTE, you know, these are the big companies which are producing basically the communication equipment, and they distribute them to countries all over the world in order to be able to let people connect with the internet. So most countries are dependent on these companies. For example, if you think of your country, you will, when anybody mention the word communication for you, it will come to, what comes to your mind is mobile operators, like if we talk about Turkey, it comes to our mind Turk Telecom, Vodafone, Turkcell, and so on and so forth. If you talk, for example, about your own country, you will think of certain communication companies. These communication companies, all of them are basically providers for the service of wireless, of connecting people with the internet. They are not basically the ones who built the wireless infrastructure or the communication network. So if you want to become an expert communication engineer, so you need to be able to not just consume and use the technology and make use of it as a business, but also invent and produce and manufacture devices and equipment so that you own your network and you avoid being dependent on companies that can give up on providing you devices if any conflict happens between your country and the country of the manufacturer. That's why, for example, we have seen Trump in USA calling for motivating and encouraging US companies to be totally independent from Huawei equipment. And they consider this a national security issue, that our country should not take or buy devices from countries that are, from companies that are not Americans. And if we take this just like an example, then all the other countries should, at least they can feel that this is a critical important issue. And if you ever want to be independent and you want to be of power, you have to have your own technology, and you have to be self-reliant. You shouldn't depend on other companies to provide you with their equipment, because you don't know what they have put in these devices. They might be spying on you or in your users and citizens, and it's the job of the government to protect its users from using these equipments and devices and services. But usually, most countries, they don't have the technology, they don't have very high-tech companies that can produce these devices, because the knowledge behind producing these devices is kind of secret knowledge, not shared on the internet. You won't find this, like if you search on topic like how to learn programming, things related to computer, most often you are gonna find tons of material on that topic. You can easily read about it, learn it, and do it. But if you are gonna search about things like how to build a wireless infrastructure, how to build these devices, how to manufacture them, you will not find anything except a few things that they make sure that they are lacking many key parts in them, so that you cannot build them by yourself. You have to consult and take advice from the people who have produced this leaked material on the internet. So the main challenges, first, you need to provide high data rates with no errors. So this first challenge gives us two things. You need a high-speed internet and low errors in the communication link. Means reliability and throughput should be extremely high, depending on the application you are using, of course. Second requirement is energy efficiency. Your system should be extremely energy efficient. This is a challenge that most engineers who are building the communication devices are faced with. Why energy efficiency? Because what's the point of using a mobile device whose battery can run within a few minutes? It's not gonna be effective to keep charging it. You know, this is one of the key points. One of the key points that companies which are producing smartphones are competing on. Like which smartphone his battery can last longer is gonna be much easier to sell. If you can ever find a smartphone whose battery cannot run out at all for 10 years, it would be like a marketing point for that company, and many users will come and buy that phone from you. So companies nowadays, I know they are competing on the camera resolution, competing maybe on the memory side, on the hard disk size, and some other features. But one of the key features that are key in making your device really very attractive device is the energy efficiency of that device. How often do you need to charge your device? This is a question that should be asked by customers whenever they want to buy a device. The same thing applies to the network side. So your network should not be power hungry. So the more you save power, the more your system will be economical, and the more revenue you will generate as a business or as a company. The second problem we have in wireless systems is the scarce spectrum. The scarce spectrum, we already maybe mentioned this in some lectures, like the spectrum is basically the band over which you are allowed to transmit and receive your signals. And when you think the band, when I say the band means it's basically the air. Now, the air of a country is controlled by government. So the government is responsible for regulating who's allowed to transmit signals over this band of spectrum. Now, most companies, most private companies, mobile operators, have to buy spectrum licenses from the government so that they can use this spectrum with the devices they buy from Ericsson, Nokia, and Huawei. We call these companies vendors. So if you were to build a wireless network that can cover a city, like let's say Antalya, and you need to install base stations like those ones to cover the city very well and to be able to serve all the users in that city. So to make these devices run, the devices need spectrum. The spectrum, you cannot transmit over the spectrum without getting a license from the government, because this spectrum that you want to transmit over might be used for other applications like navigation by military or TV or FM or station. So if you blindly start transmitting over that bunch of spectrum without consulting the government or without taking license, first you will cause interference to others, and other company will start fighting with you because you interfered with their systems. The second, the government will fine you, like they will put punishments and charge you lots of money for breaking the rules. So to avoid this, as a company, you need to go to the government and apply for getting license. Now, this procedure is extremely a very lengthy procedure, usually in most countries, very difficult. And not only this, but very expensive as well. So usually companies buy this 1 megahertz of spectrum for millions or billions of dollars, depending on where you live. So if the spectrum is scarce and is limited, then as a communication engineer, your first job would be how to send data in this spectrum in a very efficient manner so that you don't waste any of it and you squeeze as much data as you can within the limited band you have bought from the government. So this is one of the key requirements, one of the key things that companies look for when they are hiring engineers. They want to find engineers who can optimize their systems, who can come up with algorithms and techniques and methods that can make their systems efficient, reliable, and serve more users while being limited in bandwidth, in spectrum. The fourth challenge is reliability and coverage. this challenge is related, how far can you make your signal propagate? Let's say you install a base station in the center of the university. How far your signal can go? How far your customer who's connected with your tower can really get reliable access from you and access the internet without having any degradation or any errors in the received packets at its side. So this is really one of the major issues in wireless systems. That's why we see some spectrum is more expensive than other bands of the spectrums. And the reason for that is the capability of some signals at certain frequencies to propagate farther than other signals. So we know from physics that the lower the frequency, the easier for it to propagate through the air because it doesn't get affected by obstacles like buildings, trees, and objects. But if your signal is very high in frequency, then the wavelength is gonna be extremely short. And in this case, your signal will be extremely affected by obstacles like building, trees, cars, and anything in between the transmitter and receiver, and therefore your signal cannot propagate far enough. If your signal cannot propagate far enough, this means that you cannot really serve the users who are far from you. You can only serve users who are located within few meters away from you. Of course, this is not good from business perspective because you need to serve as many users as you can so that you get more money, more revenue, and therefore once you have more money coming into the company will invest in expanding, improving, and making the business more successful, and eventually producing new services and applications to the end user. So that's why coverage is really important. For example, the frequencies located in the range of 400 megahertz to 1.9 gigahertz, we call them the golden frequencies. Why we call them the golden frequencies? Because they are more expensive than gold. Not more expensive, it's like, think of it like 1,000 times more expensive than gold. Just 1 hertz of them, buying 1 hertz of them, thousands times more expensive than gold, more than this even. I told you dependent on where you live. So the fifth challenge is heterogeneous networks. Now, you know, things are becoming more complex. We have many different networks are trying to coexist with each other because nowadays the data rate we are getting from Wi-Fi access points sometimes is not enough to provide very high reliable augmented reality, for example, applications. Augmented reality, we all know that you need at least 2 gigabit per second data speed. So if Wi-Fi access point cannot provide this, then how are you gonna satisfy the requirements of the user? Yes? If your access point has a limit on its speed, let's say 300 megabit per second, and we have 5 users in the range of this Wi-Fi access point, and all of them want to access to an augmented reality application, and each one of them requires 2 gigabit per second. What will happen? The Wi-Fi access point will crash, will not be able to respond to all of them. The application, the augmented reality application, is not gonna work successfully. It's not gonna meet the customer's expectations, and therefore the business also not gonna succeed. To solve this problem, the engineers started thinking of why, if one system is not capable of providing enough data rate to our customers, then why don't we connect this customer simultaneously with another network like 5G or 6G or this or that? so that we can balance the load coming from the users, and make sure that all of them can simultaneously be served with enough data rate, and all of them will be able to run their applications seamlessly without any interruption, and accordingly give good feedback to the company they are connected from, and then happy customers, successful company. The cycle will be complete, and the customer will be happy because his application is running seamlessly without any interruption, and he's enjoying the augmented reality services. And the company also would be happy because if the customer is happy and he's able to use his app, then the customer wouldn't mind paying the fees of this service to the company if he's enjoying it and making more money than what the company is getting from him. And the sixth challenge is seamless inter-network handoff. So assume you are moving in a car now, or you are in a bus or a train, and crossing the range of one base station to another. So what will happen? Let's say you are currently connected with base station 1, and all your data is coming over this, coming via this space station, and you are crossing the border of this space station. Basically, when you cross the border of this space station, you are no longer receiving high quality signal from this space station, and therefore to stay connected with the internet and to keep receiving your data successfully and keep using your video service or your call service or whatever service you are utilizing, you have to offload to another base station that can provide you with the service you are requesting. So this process, we call it handover. So the problem here, how to make this handover as smooth as possible to a level that the customer wouldn't feel that there is any degradation or any interruption or any switch from one base station, one tower, one cell to another. So this always has been challenging, and it has many trade-offs and many requirements, and a good system design should meet all of these things and should strike a very good trade-off. Otherwise, customers will be complaining about all of a sudden my call dropped, all of a sudden the connection got cut, I don't know what happened, and things are not gonna be pleasing at all to anybody, neither to the customer side nor to the company side. So beside this, we have also challenges related to the block length of the transmitted packets. We have challenges related to the latency. Can I make my system can I send my data, instead of taking 10 milliseconds to go forth and back from the base station to the user, can I send it within 1 millisecond? So this is very challenging in current wireless systems, and therefore companies are looking forward to bring and invent new technologies that can make this possible. Then one might ask and say, why should we need 1 millisecond latency communication links? I mean, we are okay right now with 10 millisecond. Like, this is the latency. 10 millisecond is the latency you get when you are connected to a 4G network. So the reason for this, the reason why we need networks with low latency, 1 millisecond or less, is the fact that the future is expected to be completely different from the current era we are living in. So therefore, the applications are gonna be different. And one of the key applications in the future that many companies are expect to be emerging is the driverless car. most people will have not only electric cars, but also driverless cars. So this, we call them self-driving cars. Cars that are self-drived, they don't need drivers. And these cars, all these cars, are completely dependent on having very reliable and low latency wireless connection in order to make it possible to happen. Without a very reliable low latency communication link, you can never ever enjoy driverless car. You can never have a self-driving car because one of the key thing is latency. Why latency is important in self-driving cars? Because assume the car is moving with a speed of 100 or 150 kilometer per second, and assume the self-driving car just sees all of a sudden an object, and it has to slow down the speed a little bit before it crashes with this object. So in order to be able to react to this event, your communications should be extremely fast that it can react to this object with the same response that a human can react to. So how can you achieve this? To achieve this, you need to have a very reliable low latency communication so that it immediately triggers the object and sends the data extremely very fast to the network, and network immediately take action that immediately stop the car, make sure it doesn't crash, and avoid accidents at the end of the day. So that's why latency is very important here. So these are the challenges related to the network side and radio side. Now we have also challenges related to the device side, system on chip challenges. So when we talk about the device side here, we are kind of talking about smartphones. So when you talk about your smartphone, what do you like to see in your smartphone? Right now we see customers going to the shops, shopping online for smartphones. Whenever they hear a new brand or a new model being released by Apple or other companies, they rush out and they want to buy that new model. Why? What's that thing that drives them to really make them believe that the new one is gonna be better than the previous one? Is because companies are trying to provide always better devices, trying to innovate, trying to come up with something new so that they are not left behind and they can always be very competitive compared to their rivals, and they can make sure that their customers are always happy with their products, and then they can bring other customers to buy their products, because once the customer is happy from their product, they can tell others about the benefits and the features and the capabilities of the new smart mobile phone, and therefore more users will come and buy, and accordingly the company will become more successful. So one example of these companies that has become recently successful in spite of the extreme competition in this market is Xiaomi. Xiaomi phones, like you see, Apple phones are really great, but like they are very expensive. Samsung phones a little bit less expensive, but they are lacking many features of Apple. So Xiaomi came in and tried to bring some features from here and make sure that the price is really affordable to most people. That's why the sales of Xiaomi, for example, from mobile phones nowadays is even more than almost competitive and similar to Apple and Samsung. It's very close, very close. And Xiaomi was like, it has been, nobody knows it before 10 years. Within just very short period of time, it was able to catch up and to provide a new alternative smartphone solution for people that can combine both the price edge and the reliability edge, the quality. So when you look at your smartphone, you look basically at your camera. You want your camera resolution to be as high as possible. You want the memory to be high, the RAM, because when your RAM is really good for your phone, then it means that you can run multiple simultaneous applications without any degradation or without any delay or without any hanging up. So your system will be really meeting your requirements and your need. And also you look at the like room memory kind of like the hard disk or the hard drive, how much space you have in your mobile phone to store your photos and to download apps and to store videos and so on and so forth. So the companies right now are competing in this direction. All these are under the word performance. So when you hear the word performance, it means RAM, room, CPU, battery, it means camera resolution, all these things that companies compete with each other in order to provide customers with very good mobile smartphones. The second challenge is complexity. How to make sure that the design inside your mobile phone is of low complexity. Why this is important? Because if you design something low complex, you will end up enjoying many other benefits. Basically, the size will become low, the power will reduce, and the cost will drop. And therefore, you will become more competitive as a company. So the second and third point are interrelated. Once you have one of them, it automatically means the other. Beside that, our devices should be able to support high frequencies, millimeter wave frequencies. Why we need our phones to support millimeter wave frequencies is because of the expectation that the future is going to be different than the present, and augmented reality, virtual reality, mixed reality are extremely gonna be pervasive and widespread, and people are gonna be using them like insane, like in their daily lives, in their daily activities. And the current wireless systems, they cannot afford serving like thousands of users using augmented reality related applications at the same time with the current wireless technologies like 4G and Wi-Fi. The only solution to this problem, as some scientists say, is to go up in the spectrum and make sure that you have plenty frequency range so that you can increase your data rate, and accordingly you can serve all the customers who are using augmented reality related applications. So millimeter wave and high frequencies are needed when you talk about virtual reality, augmented reality, things like those. Why? Because we already explained to you before that the spectrum is scarce, the spectrum is limited, the spectrum is expensive. So the only way to provide higher data rates communication link is to go up in the spectrum, because once you have more bandwidth, then automatically you will get more data rate. You will be able to serve high-speed connections. Beside this, if the high frequency is not enough to provide high data rate connections, then what other possible solutions we can come up with to solve this problem? We can utilize antennas. We have to make sure that each device can be equipped with not just one antenna or two antennas. We want to embed more than 4 or 5 or 8 if possible, with minimal cost. Now this is very challenging. Now we understand that our mobile phones, most of them, they have only one receiving, one transmitting antenna. Some of the new phones, the advanced one, they have two antennas. That's why they have high-speed uplink transmission. But if you want to get and enjoy really high data rates, your phone has to be capable of like having more than one antenna, more than two antennas, at least 4 or 8 antennas at the same time. And all these antennas are sending data simultaneously. So if you can transmit 1 gigabit per second in 5G technology with one antenna, when you get 8 antennas, you should be able to send with 8 gigabit per second. So imagine the impact on your data rate when your device has more antennas. Your data rate will significantly get multiplied by the number of antennas, if you are, of course, using spatial multiplexing. Beside that, if your phone right now, most smartphones, they have a Wi-Fi chip, they have 4G chip, they have 2G chip, they have multiple radio interfaces. And if you need to reduce the cost and make the system design more efficient and more cost effective, then you need to think of ways of how to really combine all these systems together while making sure that they don't interfere with each other, so that we can provide phones with cheap prices, and therefore we can end up as a company having more customers. So this is also a problem that engineers are looking for when it comes to device manufacturing. The last point is coexistence between not only different technologies, different radio technologies, but coexistence with other devices like wearable devices. Your watch, your smartwatch, your smart ring, your smart devices, whatever, your smart sensors, smart actuators, the things that they are connected to the internet, how you can also coexist them with your mobile phone while making sure the cost doesn't increase too much and the complexity of the system doesn't scale with this. So all these are challenges that are related to the device side. So now we have challenges related to the network side, challenges related to the to the device side. Now, most of the research work happening in the literature is basically dealing with one of these challenges, or maybe some that they are related. I mentioned some extra challenges here which are not written over here, but like usually any paper you find in wireless systems, in communication or computer, most of them are their goal is to improve one of these or multiple of these. Anyone who can do any improvement in any of these things, it's considered a contribution, not only to the science, but also to the industry. And this is what we are doing, like with my master students, with my colleagues, with the people I work with, and most researchers as well. They are trying basically to improve and come up with techniques, methods, algorithms, schemes, designs, whatever, that can really improve the system in one aspect, like hopefully in more than one, like multiple of these, and try to make sure that these new techniques don't bring new challenges with them. Yes, we want to improve these metrics, but also we don't want to mess up with the others. So the key challenge here is how to improve, for example, energy efficiency while not affecting all the other parameters. This is the difficulty. So you have to be really careful when you are coming up or inventing or producing a new method, because most often when you come up with a method that can improve one thing, it's gonna affect other things. And usually most researchers, most people, what they do, they just focus on the advantages and merits and benefits of their technique, and they usually forget about all the other things that their technique messes up with. So that's not good methodology, not good way of doing research or presenting your method, because we are not just business here trying to sell our products, but we have to be fair and transparent with the people who read our research, with the people who implement our techniques and want to build on top of them. So they have to know the advantages as well as the disadvantages of the technique. Many people might get scared of this. They don't want to show the weaknesses of their techniques. Therefore, they don't talk about them. But usually for researchers, this is gonna be seen and perceived as research opportunities for them. So don't be afraid of disclosing the limitations of your technique while you are doing research, because most of you are gonna be doing research at some point of your life. You are doing your thesis, you are doing this. So when you come up with a technique, you need to know its advantages, and that's basically the key motivation why you are doing this research. But also, you shouldn't be blinded on the disadvantages. You have also to look at them, investigate them, see what parameters it affect, and how things are interacting with the system, with the current existing systems, and highlight and mention in your thesis or in your paper or anything, or in the technical report you are writing, that yes, true, my technique can do this, do that, all these things are great, but on the other hand, it affects the following parameters, 1, 2, 3, 4, 5. You mention them to be transparent and to be clear and fair. Now, don't think that this is a bad thing. This is not a bad thing at all, because when some other researchers come after you and see your work and get excited about the advantages it provides, but they see that there are some other disadvantages, so it motivates them. It kind of motivates them to work on reducing the effect of these disadvantages and make sure that they increase the good points and reduce the negative bad points in your technique, which is a very great thing to see related to your techniques or methods that you invent. You see people who are working on improving them in the future. If you don't disclose these weaknesses, people usually wouldn't be keen to investigate and see what things your method are gonna affect, because they have other people who are introducing maybe more interesting stuff than yours, and therefore you will lose this advantage of making and motivating researchers to work on your technique, to improve it more and make it more competitive. So this is how we look at it. So I think for now we can stop here.